Okay, welcome back now to part 3 of our interest test review as we get down to page 3 of the sample test. One of the things I will caution you about sample test compared to your own test, the sample test is really laid out basically in the order we covered things. Your test could be more mixed up than that, so you really do have to look for keywords, not just the order stuff comes out and things can be mixed up. So as we read here, the next problem says, Daniel decides to start saving to buy a house, which he plans to buy at age 30. This one makes it really clear to you because it says right out, he sets up an annuity. We don't even have to think about it. That pays 7%. The other thing we get here is we get a clue. How much will he have to pay each month if he wants to have $100,000 when he turns age 30? We have two annuity formulas. We have annuity formula A equals principal times that double quantity, 1 plus R over N to the NT minus 1, all divided by R over N. Right, that tells us the amount that our annuity will grow to. Okay, that tells us the amount that our annuity will grow to. And the other formula we have for the annuity is the payment formula, which is A times R over N, all divided by that double quantity. And in this case, we want to know the payment. So we are actually dealing with this version. And so here we would plug in our information and proceed to work this out. So he wants $100,000. The interest rate is 7% and it's every month. And the other thing is he starts at age 17 and goes to age 30. So the time period is 13 years. So we want 100,000. That would be 0.07 over 12. And then divided by our double quantity. When you put that in your calculator, remember not to use brackets, but parentheses twice. 1 plus 0.07 over 12 to the 12 times 13 minus 1. And the other thing with all these compound interest problems is to remember that if you're going to let the calculator figure out that exponent, 12 times 13, to use grouping symbols around that, unless you have a calculator that already defaults to doing that. And when we do that, we find out that he needs to invest $394.74 each month from age 17 to age 30 to have his $100,000 for that home. As we go to the next one, Handy Manny decides time to start saving for retirement. He decides to set aside $250 each month. Again, it's a multiple time thing into an account that pays 8%. Manny's 32 when he starts. How much will he have? So now we're locked into this one here. Okay? And so we're dealing with this formula. So we plug in our information and we'll work it out. And there's actually two questions. How much will he have at 50? How much will he have at 70? Both will use the same formula. The only difference is on the first hand he's putting the money in from 32 to age 50. So for 18 years. And in the second case he's putting the money in from age 32 to age 70, which would be 38 years. Okay, so we're using our annuity formula. 250 times 1 plus, it's 8%. It's monthly. And so in the first case, it's 12 times 18 minus 1. All that over that parentheses 0.08 over 12. And then we just work that out. Okay, so when we compute, we get 120,021.53. That would be for the first time period, for the 18 years. And then we do the same thing for the 38 And when we do that, we see that it's 738, 577 and 52 cents. So there's kind of a little object lesson here. First case he's putting it in, spending 18 years putting money in. Next case he's spending 20 more years putting the money in. In both cases he put roughly the same amount in over the 18-year period and the 20-year time period. The difference is that for the second time period, that 120,000 he had basically was allowed to grow on its own for the next 20 years, and that basically is what gives you that extra money. And that's the important point of annuities, is that the time period, or any kind of investment, the time period is the most important thing, because a lot of times you can't really control the interest rate. It's going to be what it is. Higher interest rate would be better. We can't always deal that. Okay, we're going to stop here in this video. We're going to come back one more time and do this final problem in part 4.